Hi everyone. In the last session, we have seen the use of type def statement. After that, we have discussed some of the important gate examination questions on structures. In the same session, we also implemented some of the programs using structures in Visual Studio Code. In today's session, we are going to write some more programs using array of structures and array of pointers. At the same time, we will implement type def statement using Visual Studio Code. Let us start the first program using array of structures, array of structures, array of structures, array of structures. Now, before going to write the main, create a structure using the keyword struct student opening brace, and you take some fields character student name, and you give the size 10, and next you take the next variable name integer rule number, and you take another variable float marks. Now, at the end of the closing brace, you can put semicolon. That means we are not going to create array of structures before the main. Next, to start from integer main. Now, within this main, I'm going to create an array of structures. For that, again, you have to use struct student, and here we are using the name of the variable s, and here I'm mentioning s of 5, means I'm going to read the information regarding 5 students in a class, s of 5. Next, here I'm writing the variable integer I for reading the information into the structure, array of structures. After this, what I'm saying is printf, enter the details of 5 students, 5 students, slash and double quotes close. Now use for loop for, you write I equals to 0 and I is less than 5, and you say I plus plus, and you here read, you write scanf. First we are reading percentage yes, percentage d, percentage f, double quotes close. First one is string, right? S of, first one is s of 0, s of 0 dot s name, not s name here, s of 0 dot s name comma ampersand s of 0 dot, s of 0 means here you have to mention not 0, here you write I, here also you write I, s of I dot rule number comma ampersand s of I dot marks. So this is the way of reading the elements into the array of structures. S of I dot s name comma ampersand s of I dot rule number. Okay, here s name, here not s name, you change s name. Now after reading the data into 5 structures, now you have to display the same. Now you write printf the details of 5 students. You write 5 students, just you display them. Just you copy the same 2 statements, control C, and you write control V. Instead of writing scanf statement, just you write printf, remove ampersand here, ampersand you remove, here also you remove ampersand. Now last statement you say return 0 closing brace. Now we will see whether we are going to get the output or not. Save the program, control yes. Now run it. there is an error in the for loop that we will see what the error. I equals 0, I is less than 5, I plus plus. Printf, enter the details of 5 students. Okay. Here one important thing is we have not written hash include stdio.h, right? Hash include stdio.h. Okay. Now you say Control S. Now you run it. Getting error. What the error? Check the error. Here we have missed the semicolon, right? Just we have missed the semicolon. Now you say Control S. Now try to execute again. It is going to take the elements, right? Enter the details of 5 students. See, first I'm giving the name of the student, first student, Sunil. Next rule number 10, March 234. Next, I'm giving the name Anil. Rule number is 34, March 5567. And next, Suman, third name, 3456. Next, fourth name, PS Rao, 5566. Next, another name you are giving this, 3556. You see here, it is reading the details of 5 students and it is displaying the same. This is the way of reading the elements into array of structures and printing those elements. If you want to have the output in line by line, just you can write here %s/n, %d/n, and here also you can mention the /n. This is the way of using array of structures. Here we are using array of structures. See here, instead of you typing every time struct to student, I can redefine it by using typedef statement. Already we discussed that typedef statement is going to create a new name, or it is trying to give a new name for the existing data type. See, to give shortcut names for the structure, here you write typedef struct to student, and here before this semicolon, what I'm writing is just I'm writing student. That means the user defined data type struct to student, the user defined data type struct to student is renamed as the new data type student. Now, whenever you write structure variable like a student s of 5, no need of writing struct again. Just you can write student. Student becomes the name of the data type. Okay, now save it and try to execute this again. Now it is asking same details. So we will get the same output. But here what we have done, instead of writing every time struct to student, we have given the new name, new data type name for this entire structure struct to student with the name called student. Now whenever I write student, its meaning is struct to student. This is the way of using typedef statement. Already we discussed theoretically, and also we have implemented this program using typedef statement. So this is about how to use typedef statement and array of structures. Now we want to use an array of pointers. When we want to use array of pointers, what you do is first you create array of structures. See student s of 5 we have created. Now here assume that after this we are creating another variable s1 star of s1. For example, here I am writing star of s1. Here I am writing 5. What does it mean? It is an array of pointers. How many pointers? 5 pointers. See, these 5 pointers are going to store the addresses of 5 structured variables. Now here I am assuming that s1 of 0 is equals to s1 of 0 equals to ampersand of, I can say ampersand of s1 of 0, just I am using backspace, ampersand of s of 0. s of 0. So we are storing the address of s of 0, means first structured variable in s1. S1 is the pointer, s1 of 0. Similarly, we can say s1 of 1. S1 of 1 is equals to ampersand of ampersand of, you can write s1 s of 1 like that. So I'm going to copy the variables, control C, and here you write control V, control V. How many times? 5 times. So this s1 of 1 and this is s1 of 2. Here you write 2, and this is s1 of 3, and this is s of 3. Now here it is s1 of 4, and this is s of 4. Okay, here you remove this. Now take this integer variable first. Here you write control V. Okay. So we are storing the addresses of all the structured variables in this pointers, s1 of 0, s1 of 1. So we are storing the addresses of the structured variables in pointers. Now, for I equals to 0, I is less than 5. Here what you do is, instead of saying s of I dot s name, here you can use the pointer variable, pointer to member operator like this. And here also you can use pointer to member operator arrow. Here also you can use pointer to member operator arrow. But here use the variable s1. Here also you use the variable s1. Here also use the variable s1. This is the way of using array of pointers. Same thing you have to use here. S1 dot I dot s name. Here also S1, just you write S1 of I, and here you write arrow rule number, and here you write S1 I arrow of March. This is a way of writing the pointers or array of pointers. Let us save this and check whether there are any errors. Check it before getting some errors. We will see where is the error. Okay, now just you check it. Student S of 5, student star S1 of 5, S1 of 0 equals to ampersand of S of 0, S1 of 1, S1 of 2. Okay, right? We are reading this S1 of I, S name, control S, and again try to execute this. We will check any errors are there. No errors. It is asking the details of 5 students. First we are saying X 34, 56. Next we are saying Y 56, 55, 57, M 77. Next we are saying N 88, 99. Next we are saying R 55, 66. See, we got the output. This is the way of using array of structures as well as array of pointers. If you want to use pointers concept, first to create the structured variable, then only the pointers will work. This is how we can execute the programs using array of structures, array of pointers, and also we have seen the type def statement. Next, we will see the concept of unions. We will give the introduction about the unions that we will see. Now, let us start the new topic, unions in C. Before moving on to unions, let us have a discussion on the previous topic, structures. We have defined that a structure is the user-defined data type that can store more than one data member of different type, that we have already discussed. And we know that a structure is created by using the keyword struct. By using the keyword struct. Now, what do you mean by a union? Similar to a structure, a union is also a user-defined data type that is created using the keyword union. The similarity is same. Structure is also user-defined data type which stores more than one element of different type. Union is also user-defined data type that can store more than one element of different type. Now, but the keyword for the structure is struct. For the keyword for the union is union. Up to this same. But what is the difference? The difference here is if you take structure like this, struct, the name of the structure here I'm taking is book, and here I'm taking the data member character b name. B name means book name, and assume that the size here I'm taking is 10, and here next to data type integer I'm taking the data member as the pages, and next to data type is float, and the field name here I'm taking is price, closing brace. Here I'm using the variable b1. b1 is the structured variable. Now, whenever the structured variable b1 is created, then automatically how much memory is allocated for the structured variable b1? The amount of memory allocated for the structured variable b1 is here. The amount of memory allocated for the first data member b name plus the amount of memory allocated for the next data member pages plus the amount of memory allocated for the third one, that is price. That is, in the sense, book name is of type character. How many bytes? 10 bytes plus pages is going to take how many bytes? This integer, right? Integer may take 2 bytes or 4 bytes, but here I'm taking in my system 4 bytes, and price is of type float. It is also going to take 4 bytes. Total amount of memory allocated for the variable b1 is here 18 bytes. But here I'm not using the concept of padding. I'm not considering the concept of padding. That means I'm going to use the statement hash pragma pack. Means I'm using the packing. When you use the packing, then there is no concept of padding, right? So this is how the memory will be allocated for the variable b1. That means the variable b1 is going to take the total amount of memory which is occupied to all the data members. That means individually how many memory locations are reserved or allocated? 3 memory locations. One is for book name, another one is for pages, and here the last one is for price. So every memory location is having its own address. Assume that base address is 100 for the first one, and base address is 200 for the second one, and base address is 300 for the third one. Means individual memory locations will be allocated, and each memory location is having its own different base address. This is how the memory will be allocated for the structured variable b1. But when you use the concept of the union, what happened? The union is going to share the same memory location. Dear audience, please remember that the main difference between the structure and the union is only the memory allocation. Only one memory location is shared among all the data members in union, but this is not the case in structures. The memory is wasted in the structures, but in unions, the memory is not wasted. Now we will see how the memory will be allocated for the union variable. Now we will see how the memory will be allocated for the union variable. Let us take structure variable as well as union variable separately. For example, I'm taking struct. The name of the structure here is XYZ. The name of the structure is XYZ, opening brace. And here I'm taking integer variable A, and next character variable C, and closing brace. And here I'm taking the structure variable as X. This is structure. Now, in this case, what happened? The memory is allocated for A and C individually. Integer is going to take how many bytes? 4 bytes. Now, I'm taking the memory representation here. Assume that this is the memory. This is the first byte, second byte, third byte, fourth byte. So this is allocated for the variable A, and this is the next byte. This is allocated for the variable C. How many bytes? First A 4 bytes and C 1 byte. Total how many bytes? Total 5 bytes. And assume that this first A and first byte, second byte, and third byte and fourth byte, this is treated as a single block of memory, and each block is having its own base address. Assume that the address is here 1000. Means the base address of A the amount of memory or block of memory allocated for the variable A is 1000. Now this is the second block, this is a different block, and it is having, assume that the address is 2000. C is having its own base address 2000 and A is having its own base address 1000. This is how the memory will be allocated for the variables A and C once the structured variable X is created. Now, the amount of memory allocated for the structured variable X is 4 bytes plus 1 byte equals to how much? 5. 5 bytes of memory is allocated for the variable X. Means the memory is allocated individually, but here I'm not taking the padding into consideration. That means I'm using the statement hash pragma and pack1 means I'm using the concept of packing. When you use the concept of packing, don't take any other alignment consideration. That means don't use the padding. This is how the memory is allocated for the structured variable. But what I'm going to do is, now we will see how the memory will be allocated for the union variable. Now you take union, any variable you can take, what do you say? You take union variable xyz, union variable union, the name of the variable union name is xyz, opening brace, and you take same variables integer a and character c. A closing variable, here you take u1 is a union variable. In this case, what happened? We are not allocating the memory individually. So integer takes how many bytes? 4 bytes. Okay, take the memory, so which consists of how many bytes? 4 bytes. This is treated as a single block. This is treated as a single block. Okay. Now this block is having its own base address. Assume that the base address is 1000. Just assumption. Now this amount of memory is allocated for the variable A. Now next variable is C. C needs only 1 byte. The first byte, this is used for the C. Now when you take C and A, first for A entire block 4 bytes. What is the base address? 1000. If you take only C first byte, it also having the base address 1000. Means the variable A is going to contain the base address 1000 and also C is going to contain the base address 1000. Means that the variables A and C are going to share the same memory location. Now how much memory is allocated for the variable U1? The amount of memory allocated for the variable U1 will be given the size of the largest data type data member in the union. What is the largest data member here? A. Means the amount of memory allocated for the variable U1 it will be given as only 4 bytes. This is how the memory will be allocated for the variable U1. Now, finally, what I want to say that for these two variables, the same block of memory is used, or the same block is shared by A and C. When the same memory or one block is shared by the variable A and C, if you do any modifications for the variable A, the same will be reflected to the C, other variable C. That's how the memory will be allocated for the union variables. In the next class, we will see practical examples, or we will implement the programs using unions, and we will see how the memory will be allocated for the union variable practically. With this, I'm going to close the session. Thank you for watching.